At the bottom of each homework problem, there's a note encouraging students to write their own test cases. How does one write good test cases?
That's a surprisingly difficult question. It turns out that there's an entire area of software engineering practice and research devoted to testing. Huge amounts of money are spent each year on software testing. It's an amazingly expensive prospect, and thus coming up with good test cases is really both an art and a science. Formally, the basic idea behind testing is to make sure that a program implementation adheres to its specification. That is, that what you've actually written down does what we think it should do or what you were required to do. So if the goal is to make a procedure that finds the biggest element in an array, good test cases or a good test suite would give us confidence that you've done just that. Now, unfortunately, for interesting programs, there are an infinite number of possible test inputs. For example, even if you're just trying to write a program to sum the elements of a list, there are an infinite number of possible lists of numbers that you could pass in as input. We don't have time to run an infinite number of test cases, so often we write just a few and hope that they're indicative in some sense. Or maybe we hope that they would be very powerful and help us detect errors if there are errors or bugs in our programs. So one goal for writing a good test suite, for making a bunch of test cases, is to say, oh, if I run all of these test cases, I'll have confidence that there are no bugs. Well, that's easier said than done. How do we actually do it? One hint that I would give is to think about corner cases, to play a little game in your mind. Imagine that someone else wrote the program and they're trying to be deceptive. They're trying to sneak it past you and find mistakes. It turns out that the human brain is actually very good, in the same way that we're very good at vision, at finding or detecting cheating or deception when we think someone is working against us. Take a step back if you can from the code, pretend it's not yours. Take another look, a fresh look at the specification, the statement of the problem, and see what you might check. For example, for numbers, be sure to hit all the corner cases. Try 0, try some negative numbers, try some positive numbers, try some primes, try some composites. For lists, be sure to try the empty list, all the numbers in order, all the numbers in reverse order, all the numbers in a random order. If maybe the inputs are grammars or strings, try some short strings and some long strings, some grammars with and without recursion. This is really more of an art than a science, although you may be interested to learn that there are a bunch of great research efforts in automatically constructing test cases. Basic idea is this. You give me your program, and I'm going to write another program that stares at it and notices all the loops and all of the if statements. And I'm going to try to generate inputs, maybe at random, that will cause you to take all the possible branches in your program. So if you have an if statement that says if x is less than 10, I will generate one input where x is 9 and another where x is 11 to force you to go down both branches. That way, if there's something wrong on one of the branches, like you use a variable that hasn't been previously initialized, you're more likely to find it. And that field is known as automated test input generation, and it is still in its infancy. We have not solved it in any way, and that means that there's room for creativity. One of the themes in this class is that whenever there are an infinite number of possibilities, but that we can't use all of them, like in a grammar, there's room for creativity. We have to think of the best ones. We have to do design under constraint. And unfortunately, ultimately, that's the best answer I can give you here. Try to think adversarially, think about all of the corner cases. Available now are some practice problems in which I go through, essentially I pose homework problems to myself and solve them. You can find them in the list of videos. And in each one I inject a bug, a defect. I make a mistake, and I show how I would use testing and debugging, print statements and whatnot to narrow it down. If you're curious or you want a little more practice with testing and debugging, check those videos out.